All right, so this is number 10 out of 6.1. And the problem says a publisher wants to estimate the mean length of time in minutes of all adults spend reading newspapers. To determine the estimate, the publisher takes a random sample of 15 people and obtains the results below. From past studies, the publisher assumes the population standard deviation is 1.7 minutes. Assume that the population of times is normally distributed. Okay, so it says construct the 90% and 99% confidence intervals for the population means, and it says which interval is wider, and then it says if convenient, use technology to construct the confidence intervals. Okay, so let's go ahead and go through this problem here. The first thing I did, guys, I just took this list of numbers and I put them in my calculator app. Okay, so I'm going to just show you what I did. Here's my calculator app. I'm going to go to Stat. I'm going to go to Edit. And I want you to notice that I took all those numbers here and I placed them in my app, okay? So now I'm going to go ahead and go back to Stat. I'm going to calculate my one variable stats for my list 1, okay? And let's see. So my X bar, I'm going to go ahead and go to 2 decimal places. So my X bar, I would write 8.45. So let me come back here. So my X bar is going to be 8.45. And let me see, make sure that I got all the information that I needed. Yes, I believe I did. Okay. So now the next thing we need to figure out is we got to figure out how are we going to construct our confidence interval, okay? So we should be able to, so we have that. The other piece of information we have is we know that our sigma is 1.7 because it's given me that here. And remember, my n is also 15, okay? So I'm going to come back to my calculator app. Let me clear this out. I'm going to go to Stat. I'm going to go to Test. And I'm trying to come up with a z interval, right? So my X bar, we said, was 1.7, okay? I'm sorry, that was my sigma, not my X bar. My X bar was, let me come back and get it, 8.45. So this is 8.45. My n was 15, and our confidence interval, we wanted 90%, right? So, okay, so I got sigma with 1.7, X bar with 8.45, n is 15, my confidence level is 90%. So I have my lower and upper bound, okay? So it's going to be 7.73 and 9.17. 7.73, oh, it says 1 decimal place, so if it was 7.73, it'd be 7.7, oops, 7.7. And 9.2, okay? All right, so there's my answer. This should be my answer for the first part, okay? And then the second part says, let's do the same thing, but for a 99% confidence interval, okay? So I'm just gonna change this here to 99%. Okay, so my X bar, we still had 8.45. Our sigma was still 1.7. And my n was 15. Now my confidence interval is going to be 99%. So when I come back here, the only thing I'm going to do here, guys, is I'm just going to change my confidence level to, instead of 90%, 0.99. And if you notice, my lower bounds and upper bounds changed. So now we have 7.3 and 9.6. So 7.3, I'll do this in green. 7.3 and 9.6, right? So we've constructed both the 90 and 99% confidence interval, and it says which interval is wider. Okay, so what I want you to think about is, I'm going to draw a number line here, okay? And using green, because these are the ones I wrote in green, I'm going to mark here 7.3, and I'm going to mark here 9.6, okay? And then I'm going to use blue, and I'm going to go back to, what was the numbers we came up with this time? We came up with 7.7 and 9.2. Okay, so 7.7 is going to be a little bit further in, This will be 7.7, and 9.2 will be a little bit further in here. So I want you to think about this. This is my 90% confidence interval, and this one here is my 99% confidence interval. So when it says which one is wider, we would have to say that the 99% confidence interval is wider, isn't it? So again, I know I'm kind of taking a long time here to explain this, but I want you to get a visual of what that means, okay? So when I just draw that on my number line, it kind of helps me visualize exactly what's going on. Anyway, this was number 10.